Okay, chapter P7 is rational expressions. So a rational expression is a fraction with a polynomial in the numerator and a polynomial in the denominator. So it's a ratio of two polynomials, hence the name rational expression. So two examples of this. The first one, let's say we had something like 4 over x minus 2. So that's a rational expression because 4 is technically a polynomial. It's a constant polynomial. And then x minus 2 is a linear equation, so that a linear expression. So that's also a polynomial, so that's a polynomial expression. Another one, 2x minus 3 divided by 5x cubed minus x squared. So that would also be a rational expression, polynomial in the numerator, polynomial in the denominator. So before we get into doing certain things with these, we're going to be multiplying, dividing, adding, and subtracting them. Before we get into that, we have to talk about the domain. So the domain is essentially what x values can we plug in where it's not breaking any math rules. So the domain of rational expressions are going to be all real numbers except the values that make it the denominator equals 0, because we cannot divide by 0. So to figure out what these are, we're going to factor the denominator. So we did factoring last section. We're going to factor the denominator, and then we're going to set each factor. We're going to see which, we're going to set all of them equal to 0 and solve them all to see what value of x will make it equal 0. So technically, we didn't solve those types of equations yet, so I'll kind of explain it as I go. It is important, but we didn't really do it yet, so I'll just make sure I do a couple examples and kind of explain it right now. So let's do these examples. So find all numbers that must be excluded from the domain of each rational expression. So the first one, 4 over x minus 2. So we have to think what value of x will make that denominator equal 0. So what we can do is set it equal to 0. So like I mentioned, we did not solve this. This is a linear equation. What you have to do is we need to get x by itself. In order to get rid of that minus 2, we have to do the opposite operation, which is add it. So we would have to add it to the left-hand side and add it to the right-hand side to cancel it on the left. We would get x equals 0 plus 2, so x equals 0 plus 2. So we have to exclude x equals 2 from the domain. So the domain of this rational expression is going to be all real numbers except for x equals 2. Next one, we have x over x squared minus 1. So for this one, the denominator cannot be 0 once again. So we would set that equal to 0. We can factor this as x plus 1 times x minus 1. The only way x plus 1 times x minus 1 is going to be 0 is if either, I'm going to write it like this. So you may have already done this in the past, but like I said, we'll be getting into it more in depth. The only way something times something is going to equal 0 is if one of those factors is 0. So we set that one equal to 0. We set this one equal to 0. This one would give us x equals negative 1 when we subtract 1 on both sides. This one would give us x equals positive 1 when we add 1 on both sides. So those are the values that we have to exclude. We have to exclude x equals negative 1 and x equals positive 1. So you can go back and plug that in. X squared minus 1, if you plug in a negative 1, that gives you 0. If you plug in a positive 1, it also gives you 0. So one more here, x squared plus 3x minus 18. That's the denominator. We have to make sure that that's not equal to 0. So we have to see when it does equal 0. So we can factor that as x plus 6 times x minus 3. So the only way that this would be 0, if those two factors being multiplied together would equal 0, is if one of them is 0. So we set them both equal to 0. So this is something called, what I'm doing, the zero product property. So the first one, we subtract 6, get negative 6. Second one, we add 3, get positive 3. So that means we have to exclude those values from the domain. So we exclude x equals negative 6 and positive 3. So all real numbers except those values. So when we actually do this and get to the section in class when we do this, I'll go over it more in depth. Okay, so let's get into simplifying these rational expressions before we start doing any operations. So we say that a rational expression is simplified if its numerator and denominator have no common factors other than 1 or negative 1. So to simplify, we're going to, here are the steps for it. We're going to factor the numerator and denominator completely, and then we're going to cancel common factors in the numerator and denominator. That's because something like x divided by x would equal 1, so the factors cancel and they equal 1. So for this first one here, we have x cubed plus x squared divided by x plus 1. So we have to factor the numerator GCF of x squared. We'd be left with an x plus 1. We can't factor the denominator, it's actually prime down there. So we have a common factor of x plus 1 over x plus 1, numerator and denominator. We're left with x squared over 1, because remember, cancel common factors leaves you a 1. So this just equals x squared. So technically what you have to do here is you have to omit or exclude those values that make the original denominator 0. So for x plus 1, that's going to equal 0 when x is negative 1. So I'm going to say exclude, I'm just going to write it as x cannot equal negative 1. So this whole thing simplifies to x squared, but x cannot equal negative 1. Next one, x squared plus 6x plus 5 over x squared minus 25. So factor the numerator, it factors to x plus 3 times x plus 2. Oh, just kidding, x plus 5 times x plus 1. That denominator simplifies to x plus 5 times x minus 5. It's a difference of squares. We have a common factor of x plus 5. They cancel, they equal 1 after they cancel. So we're left with x plus 1 over x minus 5. So that's simplified. We don't need the parentheses in the numerator or denominator. Setting this denominator equal to 0, we can just set the factored version equal to 0. So x plus 5 equals 0, and then you set x minus 5 equal to 0, so you set them equal to 0 separately. You would end up getting negative 5 and positive 5. So those are the values that we have to omit here. So we have to exclude negative 5 and positive 5 from the domain. Okay, last one before we get into the operations, we have x squared minus 1 over 2x squared plus 4x plus 2. So this numerator is difference of squares. It's x plus 1. It factors to x plus 1 times x minus 1. In the denominator, we can factor out a GCF of 2 first. We'd be left with x squared plus 2x plus 1. And then we can factor that remaining trinomial as x plus 1 times x plus 1, two numbers that multiply to 1 that add to 2. Now we see that a common factor of x plus 1 cancels. We're left with x minus 1 in the numerator divided by 2 times x plus 1 in the denominator. So what you could do, you could leave it like that. I'm going to distribute the 2. It really doesn't matter. And I'm going to write it like this. X plus 1 over 2x plus 2. So let's see what values we have to omit here. So that denominator set equal to 0. So I'm going to skip right to the factored version now. That's 2 times x plus 1 times x plus 1 equals 0. The only way that's going to be 0 is if either 2 equals 0, which it doesn't, so we can ignore it, or x plus 1 equals 0. That will give us x equals -1. So we just have to go over here and say x cannot equal -1, and then we're done. Okay, and for the next thing here, we're doing the multiplying rational expressions. So it's essentially just multiplying fractions, but with variables in it. So the product of two rational expressions is going to be the product of their numerators divided by the product of their denominators. So to do this, we can perform these following steps. We're going to factor all numerators and denominators completely. We're going to rewrite it as one fraction by multiplying numerators and denominators, cancel common factors, and then exclude those x values that make the original denominator 0. Okay, first one, multiply x minus 7 over x minus 1 times x squared minus 1 divided by 3x minus 21. So first step is factor all the numerators, all the denominators. X minus 7 is already factored. X minus 1 is already factored. X squared minus 1, we can factor x plus 1 times x minus 1. 3x minus 21, GCF of 3, that's 3 times x minus 7. So I'm going to write this as one big fraction now. So we do need parentheses around the x minus 7 now that I'm writing it as one fraction. X minus 7, so multiply numerators. Multiply denominators. I'm just writing the 3 out front because it looks cleaner. Cancel common factors. We have x minus 7 divided by x minus 7, x minus 1 divided by x minus 1. So we have, I'm going to write it down here, x plus 1 over 3. So that's one way that we could write this. I'm going to write this two other ways also. I'll put or. We could write this as 1/3 times x plus 1. Or we can distribute it and make it 1/3 x plus 1/3. So whichever way you prefer, they're all the same thing. So setting all of these denominators, original denominators, to 0. So we have x minus 1 equals 0. That would give us x equals 1. And then 3x minus 21 equals 0. What you would do here, I'll mention it kind of quickly, you would add 21 to both sides. 3x equals 21. 3 times x, so we have to divide it to get it off the x. 21 divided by 3 is 7, so x equals 7. So those are the values that we have to omit down here. X cannot equal 1 or 7. And I'll start circling my answers because it's starting to get a little messy. Okay, and for the next one, x plus 3 over x squared minus 4 times x squared minus x minus 6 over x squared plus 6x plus 9. So before you panic and quit, factor everything, because I know it looks messy and it looks like it's pretty difficult, but once you factor everything, it gets a little bit easier. X plus 3 you can't factor, but you can factor x squared minus 4 as x plus 2 times x minus 2. And then that's going to be times, you can factor this other numerator as x minus 3 times x plus 2. You can factor the other denominator as x plus 3 over x plus 3. So I'm going to write this in one big fraction now. And we get this. So cancel common factors. We have x plus 3 over x plus 3, x plus 2 over x plus 2, and I think that's it. So we're going to have x minus 3 in the numerator divided by x minus 2 times x plus 3. And I'm just going to write this as, I'm going to FOIL out that denominator. It doesn't matter. Once again, you could leave it as is. it would FOIL out to x squared plus x minus 6, it looks like. Okay, and then setting these denominators to 0, x squared minus 4 equals 0. When we factored that, that was x plus 2 times x minus 2. Setting both of those equal to 0, we get negative 2 and 2. The other one here, we have x squared plus 6x plus 9 equals 0. When we factored that, that was x plus 3 times x plus 3. Setting both of those equal to 0, that would give us negative 3. So those are the values we have to exclude. X cannot equal negative 3, negative 2, and 2. Okay, so let's do the next thing now. So that was multiplying. So for the next one is dividing. So to find the quotient of two rational expressions, it's going to be the same thing like we did for fractions with numbers. We're going to use the idea of keep, change, flip. So we keep the first one the same, change the multiplication, reciprocate the second expression. So it's pretty much the same thing we were just doing, except with one extra step in the beginning. So let's do this first example, x squared minus 2x minus 8 over x squared minus 9, divided by x minus 4 over x plus 3. So before we do any factoring, I'm going to keep this first one the same, change the multiplication, and reciprocate the second one. Okay, so now we're just multiplying. We're doing exactly what we just did. So we're going to factor. X squared minus 2x minus 8 is going to be x minus 4 times x plus 2. I'm going to write this as one fraction right now, knowing we're going to be multiplying that other numerator, x plus 3. Then we factor the x squared minus 9, difference of squares, x plus 3 times x minus 3, times the other denominator. Once again, just skipping that step. Common factors of x plus 3 cancel, common factors of x minus 4 cancel. This is going to give us pretty clean x plus 2 over x minus 3. So omitting the values here, we're going to set x squared minus 9 equal to 0, x plus 3 equal to 0. We factored x squared minus 9. The only way x plus 3 times x minus 3 is 0 is if we set both of them equal to 0 and solve. We would get negative 3 and positive 3, and we actually get a negative 3 over here on the right side too for x plus 3 equals 0. So we have to omit those values, so we're going to exclude negative 3 and positive 3. So it simplifies to that, excluding those values. Okay, let's do one more dividing, and then we'll get to adding and subtracting. So for this one, x squared minus 2x plus 1 over x cubed plus x, divided by x squared plus x minus 2 over 3x squared plus 3. So we see that we're dividing, so automatically we should say keep, change, flip. Technically we should say multiply by the reciprocal of the second one. So we change the multiplication, reciprocate the second one, it becomes this. So now let's, x squared plus x minus 2. Let's factor every one of those numerators and denominators, and I'm going to factor and multiply them all together at the same time. So x squared minus 2x plus 1 is going to factor as x minus 1 times x minus 1. 3x squared plus 3, there's a common factor of 3 there. So what I'm going to do is actually, well, I'll write it right here, times, I'll just put a little time sign, times 3 times x squared plus 1 after we factor out that GCF. Next, first denominator, x cubed plus x, we can factor out a common factor of x. We're left with x squared plus 1. So don't be tempted to say x squared plus 1. Don't be tempted to say x squared plus 1 is difference of squares. It's not subtraction, so we can't do anything. Next one, x squared plus x minus 2. That's going to factor as x plus 2 times x minus 1. Cancel common factors. We have x minus 1 over x minus 1. X squared plus 1 over x squared plus 1. And I think that's it. So the numerator is 3 times x minus 1 over x times x plus 2. I'm going to distribute both of those. 3x minus 3 over x squared plus 2x. And let's see what we have to omit here. So x cubed plus x. If that equals 0, we factored it and said it was x squared plus 1. So from that, either x equals 0 or x squared plus 1 equals 0. X squared plus 1 is never going to equal 0 because it's always going to make the number positive, and then it's going to add 1 to it, so it's never going to be 0. So we only get x equals 0 from that one. Next one, 3x squared plus 3 equals 0. Factoring that, that's 3 times x squared plus 1 equals 0. So that's also never going to equal 0. So what I'll just kind of cross it out like that, just to denote that. So it never equals 0 because it's the same thing as the one that we just did. And what we have to do for this one, when we're dividing, which actually, did I forget in this last one? Oh, I did forget in this last one. When we're dividing, we actually have to set the new denominator equal to 0. So when we reciprocate it, we also got x minus 4 in the denominator. We also have to set that equal to 0, unfortunately. That would give us x equals 4. So we have to add that to the numbers that we exclude. So multiplying, it's just the denominators. When we're dividing, it's both original denominators and the new denominator after we reciprocate the second one. Okay, so that's going to be the other denominator after we reciprocated was x squared plus x minus 2 equals 0. We factored it to be x plus 2 times x minus 1. So that would give us x equals negative 2 and 1 if we set them both equal to 0. So those are the numbers that we have to exclude from our domain. X cannot equal negative 2, 0, and 1. Okay, so now for the other operations, adding and subtracting. So adding and subtracting rational expressions is, once again, similar to fractions. We need the same denominators. So we need common denominators. So before we do that, let's just do one where they already have common denominators. So when they do have common denominators, we just have to add or subtract the numerators and place them over that common denominator. So let's subtract 5x plus 1 over x squared minus 9 minus 4x minus 2 over x squared minus 9. So they have the same denominator, so all we have to do is do 5x plus 1 minus 4x minus 2. Make sure the 4x minus 2 is in parentheses. And it's going to all be over that common denominator. So it's going to be 5x plus 1 minus 4x plus 2 after we distribute that negative 1. Combine like terms, 5x minus 4x is x, 1 plus 2 is 3. So x plus 3 over x squared minus 9. So we actually have a couple more steps here. We can factor now. So we want to factor the denominator. It's difference of squares. Becomes x plus 3 times x minus 3. The x plus 3's cancel. And we are left with 1 over x minus 3. So the numbers that we would have to exclude from that denominator, x squared minus 9, factored to x plus 3 times x minus 3. We set them both equal to 0. We get negative 3 and positive 3. So that's what we exclude here. X cannot equal -3 or +3. So now let's do a couple examples where they don't have common denominators. So we need to find the least common denominator if they don't have common denominators. And to do that, it's going to seem pretty complicated with these steps, but hopefully it's not too bad. For the first step, we need to factor every denominator. Then we're going to list all of the factors of the first denominator, and then we're going to keep on multiplying factors of the other denominators to the factor that we already put down from the first one. And we keep on doing this until we got through every denominator, and we never have to write the same one twice. Okay, and then we just have to make sure that we exclude values that make the denominator 0 at the end. Once we have that least common denominator, we have to rewrite every expression so it has that denominator, just like we did with numerical fractions. So probably didn't make too much sense, so let's see an example here. So let's do 4x over x minus 2 minus 3x over x minus 3. So first we try to factor everything, well, the denominators first mostly. We can't factor anything, so we need to just try to find our least common denominator. So our least common denominator, go to the first denominator, which is x minus 2. So you write that down. Next, you go to the next denominator, it's x minus 3. That didn't already pop up in our LCD, so we multiply that, x minus 3. Now we're done. That's actually our least common denominator. So what we have to do is we have to multiply both fractions by something to get that least common denominator. So we have to multiply the first one by x minus 3, but we also have to do it to the numerator, so we're not changing anything. Second one, we have to multiply by x minus 2. So let's see, multiplying that in the numerator, it's going to be 4x times x minus 3 minus, and then, I'll put that over the common denominator of x minus 3 times x minus 2 minus, the next one is 3x times x minus 2 over that common denominator. So once we have these common denominators, we can just put them over the same denominator and add or subtract the numerators. So it's going to be, what I'm going to do actually first here is I'm going to, all in one step, I'm going to combine it and I'm going to distribute. So distributing the 4x, we get 4x squared minus 12x minus, and then you need parentheses, distribute the 3x, that's going to be 3x squared minus 6x. And place that over the common denominator. And now we're going to simplify that numerator. So let's distribute that negative. So it's negative 3x squared plus 6x. And then the next step, we're going to have to combine like terms. So combine like terms in the numerator. 4x squared minus 3x squared is going to be 1x squared. Negative 12x plus 6x is going to be negative 6x. That's going to be over x minus 3 times x minus 2. So what you would try to do here is, technically you could leave it like this. It's best to try to factor that numerator. If you factor the numerator, you want to try to cancel common factors if you can. There's going to be no common factors. So what I'm going to do here is I'm just going to distribute or FOIL that denominator. So we would get x squared minus 5x plus 6. And once again, the only reason I did that was because I knew that factoring the numerator wasn't going to help. It would be x times x minus 6, no common factors. Okay, so the values that we would have to exclude, so I'm actually going to skip writing it out. it would be 2 and 3. That's what would make the denominators equal to 0. Okay, next one we have 7 over 5x squared plus 15x plus 9 over x squared plus 6x plus 9. So first step, we have to factor. So the first one factors GCF 5x, that's a GCF. We're left with x plus 3. The second denominator factors as x plus 3 times x plus 3. So now we have to look at the LCD. So the LCD, just write down the first denominator. That's 5x times x plus 3. Now we go to the second denominator. It's x plus 3 times x plus 3. One x plus 3 is already in our LCD, so we only need to include one more x plus 3. So that is our LCD. So what we need to do is rewrite both of those so they have that denominator. So we need to multiply the first one. It's only missing the x plus 3. So we have to multiply by x plus 3 over x plus 3. We have to multiply the second one by 5x over 5x, because that's all that one's missing. So we're going to get 7. I'm gonna write this in one fraction right now. We're going to get 7 times x plus 3 plus 9 times 5x over that common denominator, 5x times x plus 3 times x plus 3. Okay, so I just kind of skipped the intermediate step there, knowing it's going to get combined into one fraction. So simplifying that numerator, distribute the 7, that's 7x plus 21. 9 times 5x is 45x. I'm not going to touch that denominator. So simplifying that numerator one more time, it looks like it's going to be 7x plus 45, so 52x plus 21 over 5x times x plus 3 times x plus 3. So once again, you could factor that numerator. It's not going to help. It's not going to have any common factors that'll cancel. So I'm actually just going to leave it just like that. I'm not even going to bother distributing that denominator just because it got a little messier. It's not too bad, but we're just going to leave it like that just to show you that you can. And for these denominators, when they equal 0, I am going to set them all equal to 0 and not write it down. So I'll leave that to you guys. You should end up getting x cannot equal -3 and 0 for those original denominators. Another way to do it, for those denominators not equaling 0 for these ones, just set the LCD, every factor in the LCD equal to 0, and that'll do the trick. Okay, for the next one, so I'll do one more, and then the last one I do, I'll pause the video and just have it filled. I'll have the answer for you just filled out, so you don't have to watch it. So x plus 3 over, factoring that denominator, it factors to x plus 2 times x minus 1. And factoring the second one, difference of squares, bigger fraction. So it's going to be x plus 1 times x minus 1. So let's find this LCD. So the LCD is going to be starting by rewriting the first denominator and then adding new factors after that. So we need to add x plus 1 from the second one. It already has an x minus 1, so we don't need to include that. So now we need to multiply both of those by something to get that denominator. The first one is missing an x plus 1, so we have to multiply by x plus 1 over x plus 1. Second one is missing the x plus 2, so we have to multiply by x plus 2 over x plus 2. And we're going to get x plus 1 times x plus 3. I'm going to combine this into one fraction again, plus 2 times x plus 2, all divided by that least common denominator of x plus 2 times x minus 1 times x plus 1. So simplifying that numerator, we have to FOIL x plus 1 times x plus 3. It's going to give us x squared plus 4x plus 3. Distribute the 2 plus 2x plus 4. We're going to leave that denominator alone. Okay, the numerator is going to become x squared. So 4x plus 2x is 6x. 3 plus 4 is 7. And I don't believe that we can factor that numerator. It kind of looks like we does for it kind of looks like we can for a second. Kind of looks like it does factor, but it doesn't. So I'm actually just going to leave it just like this. You can distribute that denominator if you want. Kind of messy, so I'm not going to bother. And once again, if you set all of the factors in the LCD equal to 0, you would see that we would have to exclude the values -2, -1, and 1. Okay, so for one more for this one, so I'm going to pause this right now and I'll go through and fill it out and just have the answer up here if you wanted to pause the video and work that on yourself. Okay, so here's the answer filled out. So I factored the denominators, found the LCD, only had to multiply one expression by another factor to get to have that LCD, combined it, and got that answer in the bottom right. And that denominator is messy, but I just left it like that. And I omitted those values that made the denominator 0. Okay, so one more concept here, 2 more pages, couple more examples. Complex rational expressions. So a complex rational expression, it's a complex fraction except with variables. What this means is that they're going to have numerators or denominators containing one or more rational expressions. So all this means is pretty much it's like a fraction within a fraction. So for example, that could be something like 3 over x plus 4, all divided by 1 minus 2 over x. So you can see here how we have a big fraction and then we have a couple smaller fractions inside of it. So we're going to be simplifying these. So to simplify them, all we have to do is multiply each of these terms by the LCD of every rational expression within the larger expression. If you do that, what's going to happen is every fraction is going to cancel off. All the smaller denominators are going to cancel. And then once again, we have to exclude x values that make any denominator equal 0. So this first one here, we have 1 plus 1 over x, all divided by 1 minus 1 over x. So the LCD that we're looking for here, we have 4 little mini terms. We have a 1 over x, another 1, and a -1 over x. Only 2 of those have denominators that are not equal to 1. We have an x and an x. So the LCD is actually just going to be x. So it's the least common denominator of those smaller fractions inside the bigger one. So what I'm going to do is I'm going to rewrite it, 1 plus 1 over x over 1 minus 1 over x. What we have to do is multiply the x to all 4 of those little terms in here. Technically, the reason why we could do that without changing anything is because technically we're multiplying this by x over x, and it gets distributed to both terms in the numerator and both terms in the denominator. So multiplying that through, it's going to be x times 1, which is x. X times 1 over x is 1. So next, denominator, x times 1 is x, minus x times 1 over x is 1. So this whole thing is x plus 1 over x minus 1, which is a lot cleaner, right? So we have to omit a couple things here. We have to look at the smaller fractions. This x inside here cannot equal 0 because that's the denominator. So denominator can't be 0, so x can equal 0. Also, this new denominator cannot equal 0 either, which means x cannot equal positive 1. So those are the two things you have to look out for. You have to look out for all of the original small denominators in the new big denominator. Solve all of those, set all of those to 0, and those are the numbers you have to exclude. So we get this where x cannot equal 0 or 1. Okay, so let's do two more here. So 1 over x minus 3 over 2 divided by 1 over x plus 3 over 4. So complex rational expression. The LCD here. So let's look at the LCD of the constants first, the numbers. The LCD of the least common multiple of 2 and 4 is going to be 4. And then we also have two fractions that have an x. So our LCD is just going to be 4x. Okay, so same concept as last time. What we're going to do is multiply everything by 4x. And then once again, that's going to cancel off every denominator. So technically, we're multiplying by 4x over 4x. It gets distributed to every term in there. So for this first one right here, 4x times 1 over x. The x's cancel and we get 4. Next one, 4x times 3 over 2. That's going to be 12 over 2, which is 6. So 6x. Next, denominator, 4x times 1 over x. Once again, that's 4. 4x times 3 over 4, the 4's cancel, and we're left with plus 3x. Okay, so that's what it simplifies to. All those small denominators canceled, looks a lot better. The ones we have to omit, once again, we can't let these smaller fractions be 0 in the denominator, so x can't be 0. And then from this denominator, that can't equal 0, which means x cannot equal, we would subtract 4 divided by 3, so negative 4 over 3. So x cannot equal negative 4/3 and 0. Okay, and one more here. We have 1 over x plus h minus 1 over x, all divided by h. So let's see, the LCD for this one. We have two main denominators that are not 1. We have x plus h and x. The h denominator has a smaller denominator of 1, so we don't need to even worry about that. So our LCD is going to be x plus h times x. I'm just going to rewrite that. So it's first, it's going to be x times x plus h. So we're going to multiply each one of these by x times x plus h. So we're going to multiply in the numerator and multiply in the denominator. And we're going to see what happens here. So multiplying it, distributing it into this first one, the x plus h's cancel and we're only left with x. So really nice, cancels nicely. When we do it to the other one, the x's cancel and we're left with minus the x plus h. Now when we do it into the denominator, there's only an h there, so it's just going to be xh times x plus h. So let's simplify this a little bit. The numerator x minus x actually cancels to 0, We distribute the negative to the h. We get negative h over xh times x plus h. The h's cancel. H over h equals 1. So we're going to get negative 1 over x times x plus h. So definitely a lot messier, or a lot cleaner looking than it was. It was pretty messy. The values we have to omit, I'm going to omit it for, it's going to be pretty confusing. We have to, because we don't have numbers, we have two variables. So clearly the x can't be 0, right? So x cannot be 0. Also, h cannot be 0, because that would make that original big denominator 0. So h can't be 0 either. And lastly, this factor of x plus h in our last answer, x plus h in the denominator, that cannot be 0. If we set that equal to 0 and solved it for x, that would mean x cannot equal negative h. So that comes from x plus h not equaling 0. Subtract h on both sides, that gives us that. So pretty confusing. Don't worry too much about that if that doesn't make sense yet. Like I said, we'll get into solving these equations more in depth, but I at least had to mention it for these. Okay, so that's it for P7.